everyone. It's great to see a couple people starting to trickle into the webinar. Thank you for joining us. It would be great to know who you are as you start to join. So you'll see there's a chat box at the bottom of your screen. And it would be great to know who you are and where you're coming from. So please comment in the chat and let us know where you are. I'm based in Vancouver, Canada. So we actually have a beautiful sunny day here today, escaping winter for a little bit. But Christine, a very different story for you, right?
A little bit of snow left out there. Honestly, it heats up so quickly after it snows here in DC that, I don't know, you got to get out and enjoy it while it's there. A couple days later, it's all gone.
It's like our Vancouver snow. Awesome. We have Chris Clifton from Purdue University. Hi, Chris.
Hi, Chris. It's actually my dissertation advisor.
Oh, wow. That's awesome. Very cool. All right. Well, why don't we go ahead and get started, and then any stragglers that are joining can jump in. So for today's webinar, we're going to kick it off with some introductions so you can get to know everyone on the call, and then I'll pass it off to the team at NIST to walk you through what the NIST Differential Privacy Synthetic Data Challenge is, some commonly asked questions, and then we'll move into a Q&A session. So for everyone attending, a few things that you should know. The first is that there's a chat, so you'll see that along the bottom of your screen on Zoom. And feel free to say hello, make any comments in the chat. There's also a Q&A box. So as we're going through, please submit any questions you might have in the Q&A, and we'll take those questions at the end and do an interactive question and answer session. Please try and put your questions in the Q&A box and not the chat. That way we'll make sure we don't miss any and they're hidden in conversations. So with that, I'd like to start off with some introductions. My name is Kyla Jeffrey. I'm the Director of Customer Success at HeroX, and I've had the great pleasure of working with the NIST and Top Coder teams on this project. So Therese, I will pass it over to you for a quick introduction.
Sure. Hi, thank you, Kyla, and thank you for joining those on the call. My name is Therese Manley, and I work for one of the federal government labs at NIST called Public Safety Communications Research, and I'm a prize manager on that team for the Differential Privacy Synthetic Data Challenge.
And hi, my name's Christine Task. I am from Nexus Research Corporation, and I am the tech lead on the contest. So my PhD was in differential computer science, differential privacy research, and I'll be doing most of the webinar today.
Great, thank you, Christine. Christine Jenkins.
Hi, so I'm Christine Jenkins, the other Christine, and I support NASA's Center of Excellence for Collaborative Innovation, and we are supporting NIST on this challenge.
Great, thanks, Christine. And Ward, last but not least.
Last but not least, I'm Ward Loving. I'm a challenge architect from Top Coder, and I'm the one organizing and running this competition on the Top Coder platform.
Great, thanks, Ward. So with that, I will pass it over to you, Therese, to kick us off.
Great, thank you. If you want to go ahead and advance to the next slide, that'd be great. So NIST is the National Institute for Standards and Technologies, and we are the sponsor for this challenge. Public Safety Communications Research, this area was funded by the 2012 Spectrum auction, and so our funding came out of the 9/11 situation and incident, and as a way to improve public safety communications, interoperability between public safety commanders, and finding ways to improve the lives of our first responders and also to improve the lives of our community constituents. So anyway, we are working on this competition today and throughout the next few months to help us improve data science in the area of public safety. There have been many ways for first responders to improve the information that we receive from criminal activity, or any of the floods of data information that come into our data centers for first responders. One of the ways that we might be able to improve the communications, the wireless communications of our first responders, is to understand the flood of data information that comes into these first responder dispatch centers and other means. You might recall the wildfires and other incidents that we are not able to respond as quickly, and in the future we may be able to save lives more quickly. So the data analytics and the public safety data that we are receiving help us inform that decision making, and removing private information or personal information from that data set may be able to help us in the future in ways with research and utility. So this competition is about data privacy, and I'll hand this over to Christine to talk a little bit more about differential privacy and some of the areas that we're looking at. Christine?
Okay, so approaches that we might take to de-identifying data, approaches that have been taken previously. You can imagine, you may be familiar with this. We can try anonymizing the data, just sort of taking off names and identifiable information. But the problem is that as more and more information becomes available out there, the sort of things that can identify you become sort of more and more subtle. It's very difficult to say this particular feature of the data can be used to identify somebody, when sort of any combination of features may make you unique and identifiable in the data as long as I have outside information. So differential privacy is an approach that says, rather than saying this is what we're going to do to the data to sanitize it and make it safe, it says that, so here, rather than being a set of techniques, it is a guarantee. It says that all data which is private will satisfy the following conditions. And on the probability distribution of the outputs of the process that produced the data, and we'll talk about that more in a second. I've got a picture. And this is good. So now we have a guarantee. And there's a lot of ways that guarantee can be applied. So we'll see differential privacy systems that allow the data users to ask queries about the data and they get their answers back with differential privacy noise, or they'll make models of the data that have differential privacy noise in them. The specific differential privacy application we're focusing on right now is differentially private synthetic data generation. And so the idea here is that we have some real data, which is sensitive and cannot be released. And this happens in many different contexts. This happens with statistical data. This happens with event data. This happens with transaction data. This happens with location data, call data, all of these sorts of data that people would like to be able to collect and then be able to share for analysis by researchers, analysis by advertisers. Basically this whole ecosystem where I have data that has some interest and power and I want to be able to make it available, but I can't because of privacy concerns. Then what we can do is build a differentially private, in some fashion, model of the original data and use that to generate synthetic data that has the same format as the original data, can be analyzed in exactly the same way as the original data, is useful for all of the various tasks you might want to do on the original data, but is in fact composed entirely of artificial people. There is no real people in the data. And it is, satisfies differential privacy. You cannot look at the synthetic data and trace things back to individuals in the real data. And that is the application that we are focusing on now. It's a very nice approach to the privacy problem because it looks at all of these contexts where you have a data owner with data worth money and or data important for the public good, and they want to be able to release that data. This is, data users want to be able to receive a data set and consume it. We put a differentially private synthetic data generation step in between, and that becomes possible. So, what we are doing in this contest then, this is a contest that has 3 matches, and this is the second match. And the idea is that we are encouraging the development and empirical comparison of differentially private synthetic data generation algorithms. So we'll talk a little bit about, before we get too far into the definition of the match, a little bit more about how differential privacy works. And so intuitively, on a very, very high level, the idea is we want to capture the large patterns in the data while essentially not capturing or being dependent on the individual level patterns in the data, individual level information. And this is the definition. This is the important thing. So this will be very familiar to some of you and new to others. If this is new to you, I strongly recommend back in match 1, and we have links to this, there is a lot of educational material, starting with sort of simple tutorials and going on. And I strongly recommend going through and making sure that you understand that. Is a good exercise. This is an actively growing area, but it's very difficult to get on if you just take a look at this only single snapshot, right? You've got to wrap your head around it a bit. Big concepts, though, relevant to differential privacy. The idea is we have 2 neighboring worlds and neighboring possible worlds. In one world, the way to think of it is Bob is in the data set. In the neighboring world, Bob is not in the data set. Those are the only 2 ways those neighboring possible worlds differ. Data set 1 here has Bob. Data set 2 does not have Bob. The differential privacy guarantee says that whatever process you are using to generate the data needs to be a randomized process. And so data set 1 then doesn't have a single output. It has a distribution of possible outputs, a probability distribution of possible outputs. Data set 2 has a probability distribution of possible outputs. And the differential privacy guarantee says that those 2 distributions must overlap. And they must overlap closely. The degree to which they overlap is controlled by the privacy loss factor, which is epsilon. The larger epsilon is, the less overlap we enforce, the less noise we add, the more accurate we are. The sensitivity is another important factor. Sensitivity is how much, so for whatever your process is, how much the output of that process changes if I add or remove one person. So it's a separation between these 2 possible worlds. And so these are the sort of core concepts you want to have in mind. And then I'm not going to obviously give you a full tutorial in the space of 1 slide in the middle of this, but there are full tutorials and all sorts of other material available online. Okay, so moving on, we'll talk a little bit about the basic approach to what NIST is doing here. So the first phase of this contest actually occurred over the summer. We had a conceptual phase hosted on the HeroX platform, and we received some very good entries there, describing on a high level approaches that were potential approaches to doing differentially private synthetic data. In stage 2 now, we are focusing on actual implementation and benchmarking of these approaches against each other in terms of accuracy. In phase 2, we have 3 matches. Each match has each match adds an additional difficulty to the scoring function for accuracy. And so, let's see, 5 weeks in length, so matches come in 3 parts, which we're going to get to in a second. The total price purse of the entire empirical phase of the contest is $150,000. Pretty nice. And one thing that we'll also be talking about in a little bit more detail, so as I imagine you all are interested, we have 2 requirements to get a prize. One, obviously, you need to score well on accuracy. You also need to do this while being differentially private. And so there's a differentially private review phase where we will be reviewing your algorithm initially, just doing a high-level pre-screening during the provisional phase. And then before the prize is awarded, we do a very close validation of both the algorithm write-up and your privacy proof, and also of the source code, which we make sure lines up that you're doing what you say you're doing. All right. This is the slide with all of the useful information, which is why it's got a lot of text on there. Okay, so for anybody who is new to the marathon matches, the way this works is there are 2 phases. The initial phase, the testing or provisional scoring phase, this is where you are refining your algorithm. So you have some idea, you're going to be able to, you have an implementation of your approach, you have a write-up of your approach and a clear, complete privacy proof. You submit the privacy proof and write-up on the Topcoder website. There's a link that'll explain how to do that. And you submit your code, you run your code on the 3 values of epsilon that we've specified. We also specify a value of delta. You can find the details for all of this in the problem statement. So you run your code on our data set, you generate 3 synthetic data sets. Those get submitted into Topcoder, they get scored, and you get a score on the leaderboard. And so now you have a score on the leaderboard, and you can find out how you did. And maybe, you know, better than you expected or not as good, but you can then keep refining. So you can change your algorithm, you can tailor, you can pull in, talk about this more, publicly available information. You do whatever you need to do and keep submitting as many as 6 times a day to the leaderboard to be able to improve your score. What happens at the end of the provisional match? This goes for 5 weeks. This is already started now. You can go ahead and submit now if you would like to on the website. After 5 weeks, we take the top scorers on the leaderboard and we invite them to the sequestered phase. In the sequestered phase, they have to submit final write-ups of their algorithm with clear, complete privacy proofs, including, you know, sensitivity, use of public information. There's lots of information, and you're going to keep hearing me say this. There's a lot of information on the forum. Always check the forum. Constantly check the forum. So you have to submit your complete final write-up, your source code in a readable fashion in a Docker container that we can run. In the last match, when people asked us how long, if code runtime matters, please have your code run quicker than 24 hours. But we have runnable code, and we get all of these things in the sequestered phase. We do a final validation on the differential privacy, source code review, proof review, and so on. And then we do a final evaluation on your accuracy. And for this, we run the algorithm multiple times for every value of epsilon. We do a series of values of epsilon so that we're getting a good accuracy privacy trade-off curve, and then we compare by area under the curve. We get a final ranking, and this final ranking then decides the final prizes. Unimportant note. Okay, so in summary here, we have the revision, the provisional phase, the leaderboard, where you get to constantly refine your algorithm. Then we've got that final phase where you give us your final refined algorithm, and we run it, and we evaluate it very robustly, and we tell you what your ranking is, and, you know, if applicable, we give you a prize. If you fall into the top 5, you get a prize. Are we not breaking differential privacy if we are going ahead and designing the algorithm based around the data? So no, our application here is we are looking at cases like the San Francisco fire data, which is the data that we're using for this match, or for instance, ACS data, which is a data we hope to use in the third match. We are looking at data sets that get released every year. And the idea is they are released every year all the way up until the point where somebody says, it's a problem to just go ahead and publicly release the real data, even anonymized. Now we want to do synthetic data. But you can use the publicly released data in algorithm refinements. It's already publicly released without infringing on the differential privacy guarantee. So in general, the way this works, algorithm refinement provisional testing is going to work on one data set. We're going to give you 1 year of the data. During the actual final evaluation where we decide the prizes, we're giving you a different year of the data. So there are generally assumed not individuals in common between the year that we give you and the year that we do the final evaluation on. You're basically doing expert knowledge. You're learning general properties of the data space during the refinement period. And the sequestered, so those are all safe to do. And sequestered, we're evaluating you on a different data set, different year of the data. Okay, so we'll talk just a little bit more about specifics on this, and then we're going to do questions. So a couple important things. When I talk about doing the differential privacy pre-screen and doing the submitting your data and so on, that can only be done by the team captain, and that's very important. So we'll talk a little bit more about teaming later, but only the team captain for the pre-screen and the testing. Scoring in match 1 focused on 3 marginals. The scoring in match 2 is going to be split. Half your grade, half your score is going to come from the same 3 marginal score that we used in match 1. And the other half is going to come from a new metric that is sort of row pool comparison. So this is another metric that we are able to execute efficiently. And that does a good job of capturing similarity between the data. This is a matter of taking a random row from the real data, looking at the number of rows that are similar to that row in the real data according to a set metric, and then capturing that. So there's a pool of rows that are similar to the selected row, and then capturing that same set in the synthetic data and comparing the size of the 2 pools. And again, that is fully specified in the problem statement, and there is code available. You can run that evaluation yourself. Okay, a little bit on scheduling. So January 11th, just last Friday, we kicked off match 2. That provisional refinement phase is going to be running until February 9th. And then we will have the invitations for the sequestered phase, that final phase. We'll collect submissions from you. If you've been invited during the sequestered phase to join in that phase, please watch the forums. Watch them very closely. That is the way that we'll be communicating to you. If there's any issues with your submissions, we need any other information or anything else, we'll be letting you know via the forums. So then that sequestered evaluation happens after February 9th, and then we announce the winners on March 3rd. Match 3 is starting in March 10th and going until April 15th. Here's how the prizes work out. One important note is that the progressive prize worth $1,000 is actually handed out in the middle of the match, and that will be happening here, I think, next week. So
January 26th.
Yep. So that's happening pretty soon. You want to have a spot on the leaderboard, and you want to have your pre-screening in. Pre-screening gives you an 1,000 points boost, which is a good reason to get pre-screened. So you want to have that in, and you can be eligible for getting a prize here in just a few days. And then you can see the final awards are available, running from 15,000 in this match, so more than in the last match, down to 2,000. Okay, and here are your relevant websites, and we'll start taking questions now.
Fantastic. Thank you so much, Christine. So to everyone that is attending the webinar, you'll see a Q&A box at the bottom of your screen. So please post any questions that you have in there, and we'll go through them and answer them. And if there's any that we can't answer today, we'll make sure we follow up with you after the conversation to make sure you get an answer. So my first question is probably for Ward. So Ward, how does teaming work? And what is the significance of the team captain role on this challenge?
Right. So the team captain is a pretty important role in this thing. First of all, you're allowed to form teams for this competition. The teams can have up to 5 people, including the captain. So that's the team captain and 4 other people. For this competition, the team captain makes all the submissions and is the one who submits the differential privacy proof for screening. Also, this is an important point. The team captain must be a U.S. citizen in order to receive an award. If your team does not care about being paid, then the team captain does not have to be a U.S. citizen. But in order to receive prize payment, the team captain has to be a U.S. citizen, and the team captain will also be the one receiving the prizes. So that is those are all important things. The date for the teaming is we need to receive your team form submissions by February 8th, which is the night before the submission period ends.
Awesome. And a follow-up question to that, does the team forming Google form need to be filled by just the team captain or by each team member?
So it should be filled out by the team captain, but the members of the team will need to let the team captain know what their top coder handles are, so that form can be populated.
Great, thank you, Ward.
But it does assume that the team captain is the one filling it out, yes.
Okay, and while we are on this topic, Therese, can you talk a little bit about non-US citizens participating?
Yes, certainly. The funds that support this challenge, as I mentioned before, came from the 2012 Spectrum auctions from the federal government, and through those funds and the America Competes Act, U.S. citizens are eligible for winning the prize funds. We do open that up to teams that don't necessarily include U.S. citizens, but the person receiving the funds must be a U.S. citizen, and it must be completed in bank forms after the prize awards are made. So if that's not clear, let me know.
Great, thanks, Therese. Okay, this question is probably for you, Christine.
Mm-hmm.
So if we can use publicly available data sets for refinement of the algorithm, then couldn't we just train our algorithm without privacy on this public data?
Yeah, so first of all, let me speak a little bit to the process here. So we will give you a data set that is a publicly released year of San Francisco data. We will be doing your, you have to have an algorithm that, given a private data set, could produce a high quality, differentially private synthetic version of that data set. So that's the algorithm you're trying to get to. Now, if you want to bet that, okay, so that's what you're trying to do. We're going to be doing the final validation, the only one that really counts, right? The one that decides where all the prizes go. We're going to be doing that final validation on a different year of the data set. And there's really no guarantee that that year of the data set, the distribution is going to resemble the public year that we gave you in terms of, so you could, if you wanted to believe that in San Francisco, the 2006 fires looked exactly like the 2015 fires. And so I'm going to train my, I'm going to train my synthetic data generator so that it doesn't even look at the data set that it's handled. When we go to test it on the 2015, it doesn't even look at that. It generates a synthetic data that closely resembles 2006, and you're going to assume that 2006 resembles 2015? Maybe. It's an interesting idea. It does technically satisfy differential privacy, but I think you're taking a big gamble, especially when you consider, fires, other sorts of things that can cause, I mean, it's California. They have some interesting relationships with fires from year to year. And obviously, it's not really in the spirit of developing differentially private synthetic data generators. So, in general, no. I think we're going to insist that your algorithm actually is a differentially private synthetic data generator. It actually does take in a data set and then produce a data set, a synthetic data set that resembles it while satisfying differential privacy. And for anybody who's confused by what just happened, there'll be an FAQ for this webinar too. We'll explain that in a little bit more detail. And the person asked that, please let me know if that answers your question. I think you can do that in chat reasonably well. But yeah, so the general thing is that you're able to use the earlier years for some refinement, to learn some general lessons about, properties of the data. But you do still need to do a differentially private data generator to participate in this contest. You can't just assume that I'll just spit back 2006 data and hope it's close to 2015's.
Great, thank you, Christine. So if there are any other questions around this, feel free to post them in the question box and we can come back to it. Christine, the person who asked this just posted a clarification. Maybe we can address that now before moving on.
Yeah, go ahead. Okay, yeah, so the same person, I apologize, I'm not entirely sure how to pronounce your name, but the same person, yes, so they say, thanks for the answer. Just for clarification, that means when I'm justifying my privacy guarantee only on the new data set and not on the data set used for refinement. That is true. Yes, we're giving differential privacy essentially for the data set used in the sequestered phase, and not necessarily for the one, we're essentially allowing you to learn as you do the refinement on the data set that we give you for testing.
Great.
And like I said, we'll write this up in FAQ, so it's unequivocal too.
Awesome. All right. The next one, Ward, I'm going to pass back to you. Coming back to teaming, what if team members do not have a topcoder handle or do not use it? Should the team captain skip adding the handle in the form, or must each team member register for a handle?
Yeah, I mean, we want to strongly encourage teams all the members to have the members go ahead and register on Topcoder. There is, public recognition that's associated with winning this this challenge, and we want to recognize all the members of the team and have them, formally acknowledged as part of the teams. And so if you will please register, it's a very quick registration that's minimal. It's just a few forms. So it's just a 5-minute, 5-field form at www.topcoder.com. It's very, very simple.
Yeah. I'll add briefly that strategies that have been used in the last match. If you weren't a top coder, people have used sort of their names, just their last names, last name of PI. You can use names of your research group, your university and your research group if you want to be identifiable, or names relevant to your technique, sort of whatever works. We would actually like, if there is a research group or a organization that you want to be associated with visibly on your, when we do PR about match winners and on the leaderboard, you can use it as your top coder handle. There'll also be an opportunity when you submit your write-up to let us know sort of if you win, what team name you would like to be known by. Because we would like to, make sure that you're properly recognized for your accomplishments.
Great. Okay, this next question was submitted by someone when they registered for the webinar. So what is considered public information and private information to be protected by differential privacy, such as original data set, types of columns, etc.? Okay.
So that is a very good question. We assume that the data set schema is essentially public. I mean, obviously, you're going to be publishing synthetic data with the same schema. So column names and so on, all of that is public and set. That's not something that change within. That's not something that is dependent on individuals. Essentially, you are providing differential privacy when you're done with your algorithm development and you've been invited to the sequestered phase. You are providing differential privacy for the data set that we are giving you then. And that's what, I mean, hopefully that answers your question. So in terms of where you can use public information, so this, for instance, in the FIRE data set, there are codes in the data that are related to precincts. It's fine if you want to use sort of map data to find out which precincts are adjacent to each other, what their GPS codes, if you want to involve that in your data. So you can assume that precincts that are neighboring each other may behave similarly. So sort of information like that that's generally available from San Francisco. Also, although you are essentially going to be pretending that you are, in order to be able to do this, evaluation algorithm refinement of your actual differential privacy algorithm, the data set that we give you to use during the provisional testing, you need to be treating that algorithm, you need to be treating that data set with differential privacy essentially each time you run it, right? You do need to actually have a differentially private synthetic data generator that you are running on that data. We ask that in your, but obviously we break it a little bit during the refinement process because you're doing this iteratively, which you wouldn't really get to do if you, so that's why the real solid differential privacy guarantee is for the sequestered data set. That's essentially the point at which we imagine your system has gone from the refinement phase on publicly available data to, production code that's actually providing privacy for unreleased data in our hypothetical context here. So we ask that in your write-ups, if you use publicly available data, such as that map data or other things like that, that are going to be sort of hard-coded into your algorithm and used in that sequestered phase, that you let us know where you got your data from, exactly how you're using it, and make that all very clear. But that's all that we ask for that. And please let me know if you have any remaining questions on that. Let's see,
Great. Anything else on that one, Christine, for the next one?
No, I think that's it.
Okay, so the next question is also one someone submitted and registered.
Okay, so sorry, one more question that's basically on that same thing. The number, okay, they ask, can we assume that the number of distinct categories in a column of categorical data of the data set to be public, even for private data? So the schema is made available to you. you can assume that the number of possible values for a categorical variable is public, but not the number that is actually occupied in any given data set. And that is definitely a thing. In fact, I'll just say this right now, don't hard code it. So let's say it is the case that San Francisco has a fire code that means massive forest fire. And we give you, for training, a year of data that does not have a massive forest fire, but we also give you a list of all of the possible codes. You may find in sequestered testing that you're being tested on a year that does have a massive forest fire, and there's a code that exists in that data that was not actually appeared in any instance in the training data. So you assume the schema is public, not the actual populated values. Okay, sorry, go ahead, Kyla.
No problem. Thank you for jumping in with that one. Okay, will the final evaluation use epsilon greater than 0.01?
Yes. Okay, so here's the way the final evaluation works. So we need to be able to, the whole main point of the final evaluation is to determine clear rankings between the top competitors. And so if we have two algorithms that are performing very close to each other on higher values of epsilon, we'll generally start running epsilon lower and lower until we hit a point where they distinguish themselves from each other and we can work out that ranking. In the last match, epsilons above 0.01 work just fine for doing that. I would expect that to be the case going forwards. But if we have two algorithms whose performance are just showing up at the same rank value and we can't tell which order they should be in, we will do more values of epsilon, possibly both larger and smaller.
Great, thank you. Okay. While we're talking about scoring, does the provisional scoring and algorithm refinement process violate differential privacy?
So I think this is the one that we've just been over a bit. Which was, no. So you consider the algorithm refinement process to be occurring over sort of data sets that are publicly available, and the idea is that in the sequestered phase is when that refined algorithm is being run over data that is, needs to be synthesized and has not been released, private data. Let's see.
Okay. Any advice for submitting Docker executables for the sequestered testing?
Yeah, so let's talk about executable code. If you get invited to the sequestered phase, we're going to request you send and by we, this will be top coder. We'll request that you send a executable Docker container in addition to source code and write-up that we can do the final differential privacy validation on. But you'll be asked to submit executable code, and that will get run on the sequestered data set a number of times at each value of epsilon to be able to find that ranking. And you can see the notes. If you look in the forum, you can actually see the notes on that process from match 1. So we are not grading you on runtime, with the exception that if your runtime is less than 24 hours, that's better. So we need to be able to run things efficiently enough to be able to check, enough values of epsilon. Several hours is fine. But if it's going to be a sort of very prolonged process, that may actually interfere with the scoring some. Also, please test your code before you send it over. If should be able to run on smaller values of epsilon, should be able to run on data sets with different distributions, same schema, but different distributions and populations, so don't hard code things. If you also try not to hard code the column order, so we'll be sticking to the schema. There's column labels. Use those instead of hard coding the column order. Basically things like that. And I think when we get to the sequestered phase, we may just there may be a forum post with some notes on good practices for submitting these Docker containers. Okay, just a second.
Awesome. Okay. So one additional question, and this is being asked by me, who's not an expert in differential privacy. So Christine, you'll have to bear with me if I phrase it incorrectly. But is this phase of DP event data or releases of public or restricted use statistics and microdata tables by statistical agencies?
Okay, so in the match one, so there's two data sets that we've basically been looking to target for this contest. One is the San Francisco fire data, and the other is a subset of the American Community Survey person level data. And so the ACS data, that statistical data, we expect to be more challenging. And we've actually been looking at just sort of ramping up the difficulty of both the data set and of the scoring metrics in each match, sort of raising the bar as people meet it in each match. So we are still doing the San Francisco fire data in this match. The hope is to use the ACS data in match 3. And the hope is to do some very interesting, useful things with the scoring for that match too. But we'll have more details as we get a little bit closer there. I do want to say that we are, although this is technically in the format of event data, and that will be in a different, context, right? That will be a different use case, this sort of data about people as opposed to data about events. Still, we are in general working with abstractions of the data. That algorithm developments on the fire data we expect to transfer just fine over to the statistical data. So we're not expecting, this should be a sort of a general thing. This is not like both data sets have similar properties in that they are such that individual information with a small set of features. They're not like long transactional or locational data. They have, different sort of numerical and categorical columns with different types of correlations. We really would expect to see the progress that's been made on this event data transfer just fine over to the statistical data, and vice versa. We'd expect the stuff on statistical data to work just fine for this event data. Obviously, both data sets and types of data are in demand for privatization.
Great, thank you. So we just have a few moments left. So if you're sitting on the webinar thinking, should I ask this question, and haven't typed it into the question box yet, now is the time to do so we can make sure we're able to address all of the questions that you have. A more broad question for you, Christine. So what's different about match 2 from the last match? Okay,
so I mentioned the additional scoring scheme, so that we're doing this row pool scoring too, and you can look at the details of that on the problem statement. Actually, just a couple more notes that are important here. So if you are a participant in match 1 and you are carrying on to match 2, welcome back. We would like it if you would submit, so your differential privacy pre-screening from match 1 generally carries forwards unless you make any significant algorithm differences, any significant changes to your approach. If you do make changes though, we would like you to resubmit, and when you do, we'd like you to highlight the changes so that we can see, we've been following along so that we can see the update. One other thing is that we ended up requesting this in the end. We're going to request this up front. When you get to the sequestration phase and you give us code and you give us write-ups, the code should include a code guide that lets us know sort of where in the code each of the significant steps of the algorithm are, and which sections of the code touch the real data versus which sections in the code touch only privatized data or just doing post-processing. So basically, I'll just come back to this. Always watch the forum. When we get to February 9th and we're doing invitations to the sequestered phase, there will be detailed directions on what to submit and what to look out for. Okay. So I think those are all the primary changes for this time. I think that's
awesome. And you also answered the last question I had for you in that, which is how will a contest communicate to us about important updates, questions on our entry, and final scoring? And that's the forum. So definitely make sure you're watching that closely. Anything else you'd like to add about that, Christine?
No, just it's easy to ask questions. We're pretty good about getting back quickly. Oh, I will add this actually. So if you pass, we talk about the pre-screening. So this is, you give us a clear, complete write-up of your algorithm, and your privacy proof has to actually be a proof that it's differentially private. You want to think about not so much writing for a journal article, but more writing for sort of lecture notes. Like you would to students, basically make it as easy on the reviewers as possible to understand each decision you're making and why you're making it. When you submit those write-ups, we will do reviews on every Monday afternoon, actually. Once the review is done, not too long after that, you will see a bump up on your score. So your score gets multiplied by 1,000. It's pretty significant. The people who pre-screened occupy the top of the leaderboard. That's if you pass the pre-screening. So if you pass the pre-screening, we will also be announcing on the forum on Monday afternoon the list of everybody who submitted and passed. If you did not pass, then we'll be giving you direct feedback. So you won't see the score bump, and then within a day or two, you'll get an email that says, this is the violation that we saw of differential privacy in your algorithm. And that is basically the details on the pre-screening. Okay, go ahead. Is that all we have for today? Is there anything else?
That is all the questions we have for today. So if you have any questions that come to you after the webinar, please still ask them. Like Christine mentioned, the forum on Topcoder is the best place to do so, and we'll make sure we can get answers over to you. We'll also be sharing the recording of this webinar as well as the Q&A. Actually, I'm going to pause for one moment. There is one additional question. Let's see if we can get this one in before we're up. So okay. Go for it, Christine.
Okay, sure. So the question is, do those who participate in the first round and the first match still need to submit the pre-screen even if the algorithm does not change? Also, are we allowed to modify the algorithm after submission pre-screen? Yes, so if you are participating in the first round, you've got the same team captain, nothing has changed about your algorithm from your final write-up, then that's fine. You'll hang on to your pre-screening by default when you submit. I think Ward we're set up to do that. But if you do make changes to the algorithm that are interesting, please send us a new write-up that highlights the changes, and we'll just sort of sanity check those for you. And this is helpful for us because, for one thing, it makes our lives easier when we get to the final review process. We'll have been following along as you have been evolving your algorithm. Things that might trigger you wanting to resubmit would include if you're going to start making use of a batch of public information that you weren't using before for your optimization. Or if you are sort of making a change that would affect the sensitivity of the algorithm or the way the noise is added or something like that. Just go ahead, resubmit, just highlight us, changes from whatever, we'll give you a quick check, and you're good to go. We would like to see, obviously, if there's going to be if you make some significant changes, you don't tell us about them. you get invited to the final the sequestered testing. At that point, we have to see your final write-up and the code guide, and we make sure it lines up with the code that you sent us that we're running. And we see a whole batch of changes, and they violated differential privacy. Then we will actually, at that point, you stop being eligible for the prize, and you may actually change your ranking back, remove the differential privacy validation, since you will have failed the check at that point, so you lose the point bonus and everything else. So in general, keep us in the loop. It's good for everybody. Okay.
Awesome. Thanks, Christine. And I'm happy we could sneak that last question in, so I appreciate that. As I was saying, we'll make sure the recording and the Q&A is written up from today, and that'll be posted in the Top Coder forum. So you'll be able to see that, as well as on challenge.gov and on HeroX. So lots of places to find it.
Yep.
And with that, I want to say,
one final note, remember progressive prizes. So we're handing out $1,000 each to the top 4 teams in, I guess, just the 26th. So coming up pretty soon. Yeah.
Awesome. Absolutely. Yes, that date is quickly approaching. So with that, thank you, everyone. Thank you, Christine and Therese, for joining and hosting. And thank you, everyone, for attending. We're really looking forward to this match. All right. Have a great rest of your day.